Okay, so section 1.3 is next, and section 1.3 is all about lines, equation of lines, and graphing lines. We'll also talk about parallel and perpendicular lines. So what I want you to be able to do today is graph lines in multiple formats. We'll talk about what those formats are. And then I also want you to be able to find the equations of parallel and perpendicular lines. So off we go. First of all, let's just talk about slope. Now you might remember slope is usually the letter M, and that stands for rise over run. Oftentimes we see this equation y2 minus y1 over x2 minus x1, or you might remember that as, if you don't remember it's fine, delta y over delta x. Delta is kind of the science symbol that's used for change, to represent change. So it's the change in y over the change in x. Meaning that if I have some line and I start here and I go up to here, we're saying this is how much I rose and this is how much I ran to the right. If these points were labeled, we'd probably call this one x1, y1, and this would be x2, y2. Okay, enough of that. Now the next thing I want to mention about slope is that it's a rate of change. So probably the most common one is if I have my distance on the y-axis and time on the x. Again, this comes up a lot in, say, physics. Your change now is how far did I go and then how long did it take me. So this would end up being distance over time, which, as you might know, is your velocity or your speed. I'll let your physics teacher get into the semantics of velocity and speed. Even though I do love physics, I also majored in physics in college, so it's quite fun for me. But the point here is that it's a rate of change, because the most common unit we probably think of with speed in our everyday lives would be miles per hour, which right there you see the per. That means that this is a rate of change. So that's just kind of a quick review of slope. Let's say I was given 2 points, find the slope of the line that passes through, let's just do -2, 5, and we'll just do 3, 2. Okay, so I'd say, well, my slope is 2 minus 5 over, and then I would do 3 minus -2. It looks to me like that's going to be -3 over 5. And so there is the slope for that one. Okay, now let's go ahead and continue this, and let's actually find the equation of this line. Find the equation, full equation of the line above. And we're going to do this in 2 ways. The first way I want it is, so we'll say in the following formats. The first way is going to be what's called point slope, which I actually think this is probably the best format. Your teachers will try to convince you that another one is, but I think this one's the best. And so essentially all we have to do here, we're given a point, we know the slope, and we can actually plug this right in. So the point slope format looks like this. You can write that equation down in your notes if you've forgotten it. And for y1 and x1, I can really use whichever point I like. I can use this one or this one. So I'll use the first one. It's going to be y minus 5 equals the slope, and then x minus -2. So just x plus 2. That's it, we're done. That's correct. Alternatively, you could do, let's do the other one, y minus 2. And then x minus 3. Both of these are actually correct. If you tried plugging these into Desmos, you should end up with the exact same line. These are equivalent equations. Okay, now the next one is probably what you remember from a previous class. Okay, something weird just happened. Sorry, having some technical difficulties. Let's try this. There we go. So the next one is called, oh boy, this is really a struggle. Sorry, folks. Okay, the next one is called slope-intercept. And this is your sort of classic y equals mx plus b. So you can also write that down if you've forgotten that one, although that might be pretty well remembered at this point. Now the problem with this is usually we're not actually given b. So if you remember what b is, this is the y-intercept of the line. And take a look at this information I gave you. I didn't actually give you a y-intercept, I just gave you 2 points. So what we're going to do is take one of these equations here. We're actually going to rewrite that into the format that we need. So I'll just go with the first one, it really doesn't matter. And this is really exciting because we get to go into fractions, and I love messing with fractions. I guess I prefer working with whole numbers, but fractions are great because there's so much that can go wrong. All right, so we're going to start here. It's happening again. Y minus 5 equals negative 3/5. X, I believe it was plus 2. Let me double check. X plus 2. And I need it to be in the format y equals mx plus b. So I'm definitely going to have to add 5 to both sides eventually. So just note that I will have to do that eventually. But before I do that, I'm going to distribute the negative 3/5 to each term in that factor right there. So we have this, and then, oh, I guess I'll review this. Negative 3/5 times 2 is actually negative 3/5 times 2/1. And then to multiply fractions, you just go straight across. So I get negative 6/5. Okay, now I will actually add that 5 to both sides. So it looks like I'm going to have to do a little bit more work with fractions. I'm going to have to add these. So once again, kind of on the aside here, I'll do, okay, now we need a common denominator. And so I think I get 19/5. If you want to plug it into the calculator, you can do that as well. Okay, so here is the equation of my line in slope-intercept. This is also, it's important to note, if you graph this in Desmos with these two up here, you should end up with the exact same line 3 different times. If you don't, let me know in class and we'll try to figure out what happened. Okay. So that's about it for the different formats for lines. That's all I care about. The next thing I want to talk about is parallel and perpendicular. So for parallel lines, they have the exact same slope. And for perpendicular lines, the slopes are the negative reciprocals of each other. So slopes are negative reciprocal. So what that means is that if I have one line that's, let's say, negative 3/5, then the other one is actually going to be positive 5/3. So a lot of times what we say is m is the slope goes to negative 1/m, and that basically explains that they're negative reciprocals of each other. So let's just do one more example. Let's say I want you to find, let me adjust this a little bit. Let's say you're given a line y equals negative 3 over 5x minus 8. And the point 2, 1. So 2, 1 is not on the graph of this line. I'm just saying we're going to be using this equation and this point. I would like you to find the equation of a line, first of all, parallel to this here and going through the point right here. So let's do that. I didn't specify which format, so I think you're going to want to use the easiest one. So we're just going to use point slope. And so in that case, my slope is going to be the same because it's parallel. The point is 2, 1. So that means my answer is just going to be y minus 1 equals negative 3/5 x minus 2. And that is it. If you'd like to put it into slope-intercept, you can, but that seems like a lot of extra work, so I wouldn't do it. Okay, so the first one was parallel. The next one is going to be perpendicular to that line, but going through the same point. Perpendicular and going through point 2, 1. Okay. So now in this case, the slope is going to be positive 5/3 rather than negative 3/5. And if we're doing point slope again, because it's fewer steps, we're going to have y minus 1 equals positive 5/3 and then x minus 2. And that is the answer. If you graph all of these equations, which I am going to do on Desmos, they should look perpendicular and parallel. So let's go ahead and do that. Y equals negative 3/5 x minus 8. Y equals negative 3 over 5. I'm using the fraction, the division symbol to get fractions. Now it looks like it's off screen, so I'm going to zoom out just a little bit. And then I'm going to do y minus 1 equals negative 3 divided by, let's see, it didn't like that. 3 divided by 5, x, I think it was, let's see here, x minus 2. So that definitely looks parallel. If we want to make sure that it goes through the point 2, 1, we could actually graph the point 2, 1. 2, 1. Sorry, having some troubles. 2, 1. There we go. It does go through that point. Thank goodness. And then the other line was y minus 1 equals, now this is 5/3. 5 divided by 3x, except it should be x minus 2. Those lines definitely do look perpendicular, and you'll notice they both go through the point 2, 1, so we did it correctly. If you would like to know why they're perpendicular, let me know. If enough people are curious about that, I can do a little mini lecture on that for maybe enrichment purposes. I can explain to you why the perpendicular lines have negative reciprocal slopes. But unless there's any other questions, that's it. So let me know if you have any questions in class, and that's it for 1.3.